This is part 3 of the chapter 34 lecture notes. Okay, and we had stopped here. So this is a diagram of carbohydrate digestion. Sorry, I lost my pen. So if the carbohydrate is a polysaccharide, these are the polysaccharides that humans tend to consume. Starch comes from plants, and glycogen would come from animal sources or fungi. So if you eat mushrooms or truffles or morels, any of the members of the fungal kingdom store their sugar as glycogen, just like animals. So starch and glycogen are the polysaccharides, and the enzyme amylase, which is produced by the salivary glands and the pancreas as well, will break starch and glycogen into maltose, which is a disaccharide. And then maltase will break maltose down into the monosaccharide glucose. If the carbohydrate that you consume is sucrose or maltose or lactose, those are disaccharides, then enzymes such as maltase or sucrase or lactase, as you can see, they're named for the chemical that they digest, um, would break those disaccharides down into monosaccharides. In the case of sucrose, the monosaccharides are glucose and fructose, and in the case of lactose, the monosaccharides are glucose and galactose. Maltase is simply a disaccharide composed of two glucose molecules. So this is basically how carbohydrates are broken down and the enzymes that break them down. Amylase is found in the salivary glands as well as in the pancreas. So starch and glycogen begin their digestion in the mouth, but any starch and glycogen that wasn't digested in the mouth is then finishes up being digested in the small intestine. For protein digestion, most of that occurs in the stomach, but whatever's not digested occurs in the small intestine. So pepsin is the enzyme in the stomach that is activated um, by the low pH caused by hydrochloric acid. Pepsin will break down protein into smaller chains of amino acids called peptides. And then in the duodenum, enzymes such as trypsin, elastase, and chymotrypsin will break those peptides into even smaller peptides, because you have to remember that proteins can be, in the hundreds of thousands or tens of thousands of amino acids long. So they can be broken down into peptides, which are then broken down into smaller peptides. And then those peptides are broken down into amino acids by enzymes like carboxypeptidase, dipeptidase, and aminopeptidase. And then these amino acids are absorbed through the walls of the small intestines into the bloodstream. Lipids are actually digested beginning in the stomach through uh, lipase that's produced by the salivary glands. And also there is a lipase produced by the stomach called gastric lipase. Lingual lipase is produced by the lingual salivary glands. So lipids begin their digestion actually in the stomach, but the bulk of lipid digestion occurs in the small intestine, and that is through pancreatic lipase. Um, and also by the release of bile, which doesn't chemically digest the lipid, but it breaks it down into smaller particles. We call that emulsification. This looks like the same. It is the same slide twice. Once food reaches the large intestine, once chyme reaches the large intestine, it's going to be converted into feces. So the large intestine includes the beginning portion is the cecum, and then the colon, and then the rectum, and then lastly the anal canal. Um, the large intestine absorbs water and salts and also some vitamins produced by the bacteria that live in the intestine. Um, Primarily, the large intestine just compacts the feces. That's the main objective. The cecum, which is the beginning portion of the large intestine, has a little piece that attaches to it called the appendix. And then the colon is divided into the ascending, transverse, descending, and sigmoid colon. So it kind of goes up like this: ascending, transverse, descending, and then sigmoid. And that's kind of the shape of it within the abdomen. And then the rectum and the anus. Um, Constipation occurs when too much water is absorbed and the feces are hard. And then diarrhea occurs when there's not enough water removed from the feces. And then there's a kind of a fun fact: about 1/3 of fecal matter is bacteria, living and dead. This is a nutritional food pyramid from choosemyplate.gov, which is actually a really good place to get nutritional information if you're interested. But the base of your pyramid should be carbohydrates, 6 to 11 servings of carbohydrates. I know from my daughter having diabetes that one serving equals about 15 grams of carbohydrates. Um, Fruit is 2 to 4 servings, and vegetables is 3 to 5 servings. This is what's considered to be healthy. And your proteins: meat, poultry, fish, beans, eggs, or nuts, 2 to 3 servings per day. And one serving of meat, for example, is 3 ounces. Milk, yogurt, or cheese, you should get 2 to 3 servings per day. And then um, fats, oils, and sweets should be at the top of the pyramid. You should have very few of those. Um, Carbohydrates are found in the form of sugars, starch, and fiber, as well as glycogen, which is animal starch. Glycogen is a polysaccharide that's found primarily in fungi and in animal sources, in meat. Fruits, vegetables, milk, and honey are natural sources of sugars. Simple sugars are called monosaccharides, and they include glucose and fructose. And then disaccharides are two sugars linked together chemically, and they include lactose, which is milk sugar, and sucrose, which is table sugar. All sugars and carbohydrates are primarily converted to glucose, which is what we call blood sugar. And then plants convert their excess glucose to starch. Animals convert their excess glucose to glycogen. Fiber comes from undigestible carbohydrates from plant sources. Foods rich in fiber include beans, peas, nuts, fruits, and vegetables. Fiber is not a nutrient for humans because it cannot be digested, but it does help in digestion. It helps the digestive process. It helps make you regular as far as going to the bathroom. Proteins come from combinations of 20 different amino acids. There are 20 different types of amino acids. 8 amino acids can only be obtained from the diet, and children actually require 9 from the diet. These are essential amino acids, the ones that you must obtain from your diet. Some foods have all 20 amino acids. So meat, milk, and eggs, any of those individually would provide you with all 20 amino acids. Some people cannot have dairy, so they must get their essential amino acids from meat or eggs. But people who are vegan, who won't even eat eggs or fish, can get all of their amino acids from vegetables, but they have to combine a grain plus a legume. So rice and beans is a very common meal for vegetarians and vegans, because if you have rice and beans, you're having a grain and a legume together, which gives you your essential, all of your 20 amino acids. These are the essential amino acids for adults: methionine, valine, threonine, phenylalanine, leucine, isoleucine, tryptophan, and lysine. And kids also need the amino acid arginine. And of course, they're essential amino acids, so they're required from the diet. Lipids include fats, oils, and cholesterol. Um, Even though you don't need a lot of fat, you do need some fat, because fats are essential for storage and activity of fat soluble vitamins A, D, and E. And fats provide energy, 9 calories per gram. Um, Saturated fats usually come from animal sources, and they're solid at room temperature. So butter and the fat that you find on your meat, bacon, um, and then also some plant oils, palm oil and coconut oil, are actually saturated fats, whereas most other plant oils are unsaturated fats. So obesity comes from too many calories from any source. Um, and type 2 diabetes and cardiovascular disease are seen in people who are obese. So there's an increased risk of both of those when a person is obese. And primarily, obesity comes from consuming more calories than you burn off. Although there are some other reasons, but that is the primary reason. Vitamins are organic compounds that the body can't produce, but that are required for metabolism. So we must obtain our vitamins externally. Actually, there are some vitamins that are produced by bacteria, like vitamin K is produced by bacteria in our intestines. Um, Vitamins can be water soluble or fat soluble. They can act as antioxidants, which help um, basically help your cells to live longer, be healthier. Vitamins C, E, and A are believed to defend the body against free radicals, which destroy our cells. The fat soluble vitamins are A, D, E, and K. In fact, let's go back to that. I knew there was something. This should have a K. All right. So they're A, D, E, and K, and then it tells you on this page what these vitamins do for us. And then the water soluble vitamins are B and C. Minerals are inorganic nutrients that must be obtained from food, and they help, and they can be cofactors for enzymes.